stoichiometry. The majority of stoichiometric work in industry or research is done with aqueous solutions. They involve molar concentrations and volumes of a solution rather than the molar mass and the mass of a substance. The formula we're going to find that we are going to use when doing solution stoich to calculate moles is going to be moles equals concentration times volume. As in all stoichiometric work, we are going to find that the assumptions are still the same. Reactions are going to be spontaneous, reactions are going to be fast, reactions are going to be quantitative, and reactions are going to be stoichiometric. The process is going to be the same 5 steps for solution stoich as it was for gravimetric. However, the formula choice is going to be different based on the variables that we receive. Let's try an example. So, example 1. In an experiment, a 10 milliliter sample of sulfuric acid reacts completely with 15.9 milliliters of 0.150 moles per liter potassium hydroxide. What is the concentration of the sulfuric acid? So, first step is going to be, let's write the balanced chemical equation. So, we are going to mix sulfuric acid, which is H2SO4, aqueous because it's an acid, with potassium hydroxide. Now, I know potassium hydroxide is aqueous because we have a solution of it with volume and concentration. And this looks like a double replacement reaction, so my 2 cation ions are going to exchange places. So one product I'm going to be left with is HOH, and that's going to be a liquid because it's water. And the other one is going to be potassium sulfate, and we're going to need 2 potassiums for every 1 sulfate. And this is also aqueous because it's a group 1 ion, so when I check my solubility chart, it's highly soluble. First off, I'm going to start by balancing. So I have 2 potassiums. I need 2 potassiums, 2 hydroxides, 2 hydroxides, 2 baby H's, 2 baby H's, 1 SO4, 1 SO4. So I've got a perfect balanced chemical reaction. Our second step is, of course, to write down our knowns and unknowns. So in the example, it tells us that we have an initial volume here of sulfuric acid of 10.0 milliliters. It also tells me that I have a volume of potassium hydroxide of 15.9 milliliters and a concentration of 0.150 moles per liter. Our job in this question is to find the concentration of the sulfuric acid. Now, I know ideally most of us would like to convert our volumes to liters at this time, so we have liters and moles per liter, and they would nicely cancel. In solution stoichiometry, as long as both of my volumes are in milliliters, please leave them as milliliters. We're going to be a little bit more careful with the units, but this will stop us from converting wrong. What I have found over the years is more students convert milliliters to liters incorrectly, and then that makes that some of their question is going to be wrong. So let's leave the milliliters as it is and just be more careful with our units. So we have done step 2, writing down our knowns and unknowns. Our first step of math then is going to be finding our moles of our known. And the substance where I know enough information to solve for moles is going to be potassium hydroxide. So N equals CV. Again, if you're not comfortable with this, and you are going based on the memorized formula of C equals N over V, if you need to go off to the side to move that formula around to solve for N, please do so. Now, my concentration is 0.150 moles per liter times my volume of 15.9 milliliters. So, in my calculator, 0.150 times 15.9. I'm allowed 3 sig figs from the question, so my answer is going to be 2.39. And my units, liters are going to cancel, liters are going to cancel. I am left with millimoles. So that's where I said we have to be careful about the units. Still, I was able to convert to moles, so that was a success. My next step is to find the moles of my unknown. So I am now going to try to find the moles of sulfuric acid by doing the mole ratio step. Take the moles we just calculated, 2.39 millimoles, times by my unknown, which is a 1, divide by my known, which is a 2. So it's going to be 1 mole over 2 mole. Again, moles are going to cancel. I'm going to be left with, when I divide it by 2, 1.19, and the unit I'm left with is still going to be millimoles. So again, all we're doing is paying attention to details. I've successfully done the mole ratio step. Last but not least, I would like to find the concentration of H2SO4. Now, we should have this formula memorized. Concentration is moles per liter, so that's going to be N per volume, moles per liter. We're going to put 1.19 millimoles on top, divided by 10 milliliters, and you see that our millis will now cancel. So when I divide by 10, my answer is now going to come out in moles per liter. So I answered the question. Again, 3 sig figs, 3 sig figs, 3 sig figs. Units throughout the whole question. I'm allowed one state wrong, but I got them all right. So I would give myself the 5th mark. This would again be out of 5. Notice, because I have a volume in both, or because I have a volume or I'd be solving for another volume, my volumes can stay in milliliters, because if you follow the units carefully, the units will cancel each other out and solve themselves. Okay. For example number 2, why don't you pause the video, try it for yourself, and then unpause the video to check your work. So example number 2. An excess of barium chloride solution was added to 400 milliliters of silver nitrate solution, and 5.10 grams of precipitate was formed. What was the molar concentration of the silver nitrate solution? All right, so our first step is going to be, again, to write the balanced chemical reaction. So we have barium chloride solution, so it's aqueous, and we are going to mix it with silver nitrate. And it also called that a solution. Again, another double replacement reaction. So my two cations are going to exchange places. So silver is going to join chlorine. It's a 1-to-1 relationship. So it's going to be AgCl. When I check my solubility table, however, this has low solubility, so it formed the precipitate. And then we also have barium, which is 2 plus, nitrate, which is 1 minus. So I'm going to need 2 nitrates. So this is going to be Ba bracket NO3 bracket 2. And nitrate is always aqueous. There's no case when it's not in solution. So let's balance this. 2 nitrates, 2 nitrates, 2 silvers, 2 silvers, 2 chlorine, 2 chlorine, 1 barium, 1 barium. Beautiful. We have a balanced chemical equation. Second step is going to be, let's take the question and write down our knowns and unknowns appropriately where they belong. So an excess of barium chloride solution was added to 400 milliliters of silver nitrate. So that's a volume we have of silver nitrate. We make a precipitate with a mass of 5.10 grams. Well, the moment we have a mass, we can calculate molar mass. So I'm going to add 107.87 plus 35.45, and my molar mass is going to be 143.32 grams per mole. Now, in this question, we are trying to find concentration. Again, grams, grams, my answer will be in moles, 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 I'll get mole. I do have to convert this one this time, or else I'm not going to get a nice molar concentration. So I will have to convert this to liters. I convert it this time because I don't have 2 volumes. My volumes are not going to solve my other volume problem. Therefore, this time I do have to take the time to convert. Okay, so we did knowns and unknowns. First step of math, where do I know enough information to solve for moles? And that's going to be silver chloride. So the moles of AgCl is going to be mass over molar mass. So 5.10 grams over 143.32 grams per mole. And again, I go back 4 sig figs, 3 sig figs, so I'm allowed 3 significant digits, 0.0356 moles. Now that I know the moles of silver chloride, I can do a mole ratio to find the moles of silver nitrate. Take 0.0356 moles times by my unknown is a 2. My known is a 2, so it's going to be 2 moles over 2 moles, which means nothing's going to happen. My number is going to stay 0.0356 moles. Last but not least, I'm going to find concentration of AgNO3. Again, moles over volume because the unit is moles per liter. I'm going to sub in 0.0356 moles divided by 0.4000 liters. Remember to use your full calculator number. And my answer in 3 sig digs is going to be 0.0, ooh, got to be careful on this one, 890 moles per liter. So we did our 3 steps of math. Again, when I check this over, my states are right, 3 sig figs down the page, units everywhere. I would have earned my 5th mark.